Okay, in the last section, or the first section of chapter 5, we just kind of reviewed a little bit about radicals and what you could do with them, like radicals, adding and subtracting them. And now what we're going to look at is multiplying and dividing radicals. And just like the same thing with fractions, multiplying and dividing is always a little bit easier to do than adding and subtracting. So for our first example, 2 square root 5 times 3 square root 5. To multiply these, all you need to do is multiply your like factors, if you want to call them factors. So I take my coefficients, those are the like in that part, and then my radicals, and those are the like parts. And it doesn't matter if my radicals are the same, if they're like radicals, that they both have a square root 5, it doesn't make a difference. Whatever is under the radical sign, you can multiply or divide together. So what I want to do then is I group them. I group my coefficients, my 2 times my 3, and then I can group my square root 5 times square root 5. So this would be 6 square root of 25. Everything that's under the radical sign gets multiplied together. I can simplify this further because square root of 25 is 5, so my answer is 30. When you're doing these on your own, you don't have to write this 2 times 3 and then the square root 5 times square root 5. You can just multiply those in your head. 2 times 3 is 6, or square root 5 times square root 5 is 25, and then get to this second answer. So to verify your answer means you're just going to use your calculator. So you're going to go 2 times the square root of 5, and on your calculator, that is 2.236. And then that would be times 3 times 2.236. And when you multiply, you get 4.472 times 6.7082. And when you multiply those together, equals 30. If you didn't round it, you would actually get an exact answer of 30. So to multiply radicals, 3 easy steps. First step, multiply your coefficients. Sometimes they're going to be numbers, sometimes they're going to be variables. Number 2, multiply your radicals. And then step 3 is to simplify. Okay, so that's what I did. First step here, I multiplied my coefficients. I did my second step at the same time here. I multiplied my radicals, and then once I got to that answer of 6 square root 25, I simplified to get 30. So in general then, when you're multiplying radicals, you're going to be the general statement for it looks like m times the k root of a times n to the k root of b is going to equal mn times the k root of a times b. So it doesn't matter if what's underneath the radical sign is the same, but your index has to be the same. So for this one, it was this k value and this k value. They both have to be the same. So in my example that we did in the first one, I had 2 square roots. Okay, so this means where k is a natural number. So remember, natural number means it starts at 1. And m, n, a, and b are real numbers. So real numbers, if you remember from the last units that we've done, real numbers are fractions, decimals, negative signs, positive signs, anything like that, or negative integers, positive integers. And we have to be careful because we can't do the square root or the even root of a negative integer, but you can do the odd root of a negative integer. Okay, so then that leads to our last restriction on this, is if k is even. So if that root value, that index value is even, then a has to be greater than or equal to 0, and b has to be greater than or equal to 0. So all that's saying is that if k is an even index, then you have to have positive values underneath the root sign. Okay, so some examples. 5 square root 3 times square root 6. Remember, when you're doing this, as you're working down your page, you put an equal sign on each of the steps that you're working on. So what I have here is 5 square root 3 times square root 6 is what I'd be multiplying together, so that would be 5 square root of 18. Now we always check to see if we can simplify these, and you can simplify this further, and this is what we did a little bit last day. You check to see, is there a perfect, and in this case, because this is an index of 2, perfect square root that multiplies into 18, and there is. It's 9 times 2. So this would be 5 times 3 square root 2, because the square root of 9 is 3. So my answer is 15 square root 2. In B, first thing you have to check and see is, are my indexes the same? Because you can only multiply the ones together that are the same. So I've got an index of 3, another index of 3, and then the other index is 3. So I'm okay there. So all I'm going to do with this one then is I have to distribute. And I'm going to write out the steps. You don't necessarily have to do this. You could do this part in your head. So I'm going to write this out as, I'm going to have negative 2 times 4 cube root of 11 times cube root of 2. And then I have negative 2 times negative 3 times cube root of 11, sorry I forgot where I was, times cube root of 3, bracket. So what I have then is negative 2 times 4 is negative 8, cube root of 22, negative 2 times a negative 3 is a positive 6, cube root of 11 times 3 is 33. And then you always check and see, can you simplify? And if you can, then you do, but this you can't simplify. And you can't simplify square root of 33, so that would be your answer. Now it's really important when you're writing these, when you're putting in the indexes, that you make your number small enough so it doesn't look like it's negative 83 or negative 8 times 3. So you have to make sure that index number fits into that little notch. Okay, I have 4 square root 2 plus 3 times 7, or square root of 7 minus 5 square root 14. I have a binomial, so I do whatever I do when I have binomials and I'm multiplying. I FOIL them. Okay, so this one I'm not going to do this middle step like I did in there. I'm just going to go to my answer. So 4 square root 2 times square root 7. So these have the same index, so it's going to be 4 square root 14. Now I'm going to do my outside, so 4 times negative 5 will be a negative 20. Square root 2 times square root of 14, square root 28. My insides are 3 times square root 7, so that's positive 3 square root 7. And then my lasts are going to be a positive 3 times a negative 15, so negative 15 square root 14. So the next thing I'm going to do is see are there any that I can add together or subtract because they're like terms, and are there any that I need to simplify because they have a perfect square in them. So if I take a look here, I have square root of 14 and a square root of 14. So that makes those two like terms. And the square root of 28, square root of 28 is the same as 4 times 7. So I do have another one that I can simplify there. So 4 minus 15 is going to be negative 11 square root 14. And this is going to be negative 20 times 4 times square root 7 plus 3 square root 7. So negative 20 and this 4 times 7, that means I'm going to pull that 2 out. So it's going to be negative 20 times 2. So I've taken care of that 4 in that root. Leaves me with the square root 7 plus 3 square root 7. So negative 20 times 2 will be a negative 40. And what I notice again is that I have square root 7 and a square root 7. Those are like terms. So what I really have is going to be negative 40 plus 3. So that's going to be negative, whoops, 37, not 33. 40 take away, or negative 40 plus 3 is going to be a negative 37 square root 7. So now that's simplified and done. So the next one says, an isosceles triangle has a base of square root 20 meters. Each of the equal sides is 3 square root 7 meters long. What is the exact area of the triangle? So you have a problem. It's given you a shape. And we need to draw a diagram. So when I draw this out, it's isosceles, so then that means my two sides are equal. So on this one, this is going to be 3 square root 7, and this side is going to be 3 square root 7, and it said my base is square root of 20. And square root of 20 is, 20 is 4 times 5, so that's going to make that a 2 square root 5. So if this is an isosceles triangle, so that means if these sides are congruent, that means these angles are congruent also. It's asking me to find the height. So the height coming down here is going to be a perpendicular distance. And from properties of triangles, what that means that when you have an isosceles triangle and a height coming down a perpendicular distance, it's going to cut this in half. So what I have then, if I'm looking at just one side of the triangle, that's going to be my right angle. This length here is square root 5. This length here is 3 square root 7. This is what I want to find. So if it's a right triangle and I'm trying to find sides, then I'm just going to use Pythagorean theorem. Okay, so I need height. So I need to find x, therefore I use Pythagorean. So if c squared is equal to a squared by b squared, or plus b squared, then by substitution, my hypotenuse is 3 square root 7, all squared, and that's going to equal, doesn't matter which I call my a and which is my b, so I'm just going to substitute square root 5 plus b squared. So if I square, and when I'm squaring, I have to square each part of this. So this becomes 9 times square root 7 times square root 7 equals square root of 49, which is just 7. And I'm not going to worry about the plus or minus in this because I'm dealing with distances or lengths, so we don't have a negative length. So then on this side, square root of 5 squared is square root 25, which is just 5. So basically a squared and a square root just cancel each other. So plus b squared. So I'm going to have 63 minus 5 is equal to b squared, or I could have substituted an x in there. I guess it doesn't really matter. 63 minus 5 leaves me with 58. So square root of 58. There's no perfect square that goes into there, so then my answer is just going to be square root of 58 is equal to b. So now I have my height. Then that leads me to finding the area, because for area I need to know base and height of a triangle. So my area is equal to base times height divided by 2. Area is equal to a base of 2 square root 5. And my height was square root of 58. And that's all over 2. Whoops. So my 2 and my 2 can cancel here. So what that leaves me with is square root 5 times square root of 58. So square root 5 times square root 58 is equal to square root of 290. Now 290 doesn't have a perfect square that goes into there, even though it's such a big number. So that is your answer. And because this said exact area, we leave it like that. So the area of the triangle is square root of 290 meters squared. Done. Dividing radicals. So same idea as multiplying with radicals. You divide numbers by numbers, or coefficients by coefficients, and radicals by radicals if they divide evenly. There's a little bit, an extra step or two when you're doing dividing by radicals, because that has to be equally or divisible completely in order for you to do all of the work. Otherwise there's an extra step to it. Okay. So in this one, what if I want to break this up, I would have 6 divided by 3 times square root 12 divided by square root 6. So 6 divided by 3 just leaves me with a 2. Square root 12 and square root 6, again, these both have the same index. They're square roots. So I just divide my numbers under the radical sign. So square root 12 divided by square root 6 is a square root 2. So 2 square root 2 is your answer. So if I verify this, 6 times square root of 12 is 3.4641. That's the square root of 12. Square root of 6 on the bottom would be 3 times 2.4495. So I have 20.7846 divided by 7.3485. Sorry, I lost my spot. And that equals 2.8284. 2 square root 2. Okay, that was my answer. So this needs to equal that. 2 square root 2 is the same as 2 times 1.4142, which is 2.8284. So to divide radicals, same basic steps as multiplying. I divide coefficients. I divide radicands. So that's the numbers inside the radical sign. And then if I need to, I simplify. So if this, in this question, had ended up being a 2 square root 8, then I would have had to simplify that square root 8 into 2 square root 2. So in general, I have m times k to the power of a divided by n to the root of k to the power of b, then this is equal to mn times root of k of a over b. And again, my restrictions are the same. K is a natural number. M, N, A, and B are real numbers. And if K is even, then A and B have to be greater than or equal to 0. Okay? Can't have a negative or an even root of a negative sign. Okay, another example. Negative 24 times cube root of 14 divided by 8 times cube root of 2. So if I break this up, I'm doing negative 24 divided by 8, and I'm doing the cube root of 14 divided by 2. So 24 divided by 8 is equal to negative 3. 14 divided by 2 means I have cube root of 7. And I can't do anything with the cube root of 7, so that's where it stays. So as long as my indexes are the same, then I can divide the radicands. I can divide the number inside there. Okay, in B, I don't have a 2 or anything to divide the 2 into, but what I can do is see if 51 divides evenly into 3, which it does, leaves me with 2 square root 17. Example C, I have square root of 18x cubed divided by square root of 3x. But it's got this restriction on here. X has to be greater than or equal to 0. And that's because this can't be a negative value. My x's can't be negative values, or otherwise I'm trying to find the square root of a negative number, so it would mean there'd be no solution. So they're both square roots. So what I'm doing is going 18x cubed divided by 3x. So 18 divided by 3 leaves me with 6. X cubed divided by x leaves me with an x squared. But my x squared here, I can find the square root of x squared. Square root of x squared is just an x. So if I square root x squared, that's just canceling the square and the square root, so my x comes out, and I'm left with x times square root 6. And you can write this as square root of 6 times x. You just have to be really clear and really careful that you don't extend that square root sign so that it goes past the 6. Hey, rationalizing the denominator. We talked a little bit about this last unit, and I said the textbook kind of gets confusing because you don't actually do the rationalize the denominator steps until chapter 5, but you're doing them in chapter 4, and that's because you did do some of it when you were doing grade 10 foundations and pre-calculus. So the rule with radicals is that you can never leave a radical number in the denominator. It's called rationalizing the denominator. So to fix this, it says you must rationalize the denominator. I'm repeating myself. A process that will eliminate the radical from the denominator without changing the answer. So it's kind of like everything that we've done so far. If you do the same thing to the top and the bottom, you're not changing your fraction. If you add and subtract a value to an equation and it's the same value, you're not changing the equation. So If the denominator is a radical monomial, you multiply the numerator and the denominator by the radical. So in this first one here, this is just a monomial. I'm not adding or subtracting anything onto this square root 5, so that means that I just take the radical and I multiply it to the top and the bottom. So I go square root 5 times square root 5, because square root 5 times square root 5 is just 1. 1 times that fraction is just going to be that fraction. So this ends up as 6 square root 5 times 7. Square root 5 times square root 5. Basically all you're doing is you're getting rid of the radical sign, so the square root sign, and you're keeping the value. So this becomes 7 times 5. Okay? If you're thinking about, you're confused what I did here, square root 5 times square root 5 equals square root of 25, which is just 5. So that's the long step or way of doing that. The short step is just to think, I'm getting rid of my radical and keeping the value inside. So this then equals 6 square root 5 over 35. And then that answer is done. So B, 2 square root 5 divided by 3 cube root of 6. Now you have to be careful with these ones because you need to get rid of that cube root of 6. But if I just multiply it by a cube root of 6, I've only multiplied it once by that. I need to have 3 of those all together. So what I have to do then is, since this is only being used once, what I'm going to do then is I need to do it 2 more times, which means I'm going to multiply by the square of that. And I do that, I'm going to run into a little crunch here because I'm too close to the top, but cube root of 6 all squared. Because I need to have in total 3 of those in order to get rid of the root on the bottom. So this has an index of 3. I go 1 less and I have to multiply it by a squared of it. If this had been a 5 here, then I would have had a 4. If my index here had been a 5, then this value here would have had to have been a 4, so that altogether there's 5 of them. So when I multiply, I have 2 square root 5 times the cube root of 6 squared, which is 36. And on the bottom, what I've done is that my 3 stays, because I haven't done anything to change that. My cube root of 6 times cube root of 6 all squared. Same idea as with this up here. All I'm doing is getting rid of my index value and keeping the number. So this becomes 3 times 6. So what I have then, these are not, let me underline here, this and this do not have the same index, so I can't multiply them together. So I have 2 square root 5 times the cube root of 36, and cube root of 36 doesn't break down. I don't have a cube that will multiply evenly into there or divide evenly into 36, because 2 times 2 times 2 is 8. 8 doesn't divide into 36. And then 3 times 6 on the bottom is 18. But I'm still not done simplifying. My 2 will divide into 18 9 times. So my final answer is square root 5 times cube root of 36 all over 9. So when you get questions like this, you're going to have to watch and see. If my index is just a 2, then I only need to multiply by one set of that root value or of that radical value. But if it's anything greater than a 2, you're going to have to multiply by 1 less than the index value. In example C, in the denominator in this one, it has a -2 tacked on or included with that square root x. So that makes that bottom a denominator. So if the denominator is a radical binomial, you multiply the numerator and the denominator by its conjugate. Conjugate is just a fancy word for opposite. So basically all you're going to do is you're going to multiply by the opposite sign. So this one here, it's the square root x minus 2. The conjugate would be square root x plus 2. And the reason why we multiply by the conjugate is then when we multiply through on the denominator, it's going to leave us with 2 terms instead of 3 terms. Okay? So conjugate is just opposite sign. So if I had x minus 17, the conjugate for that would be x plus 17. If it was y squared minus 12, the conjugate would be y squared plus 12. Okay, so when I multiply through on here, on the top one, I'm going to have to distribute. So that leaves me with 3 square root x plus 6. And on the bottom, square root x times square root x, and I'm going to do that right here. Square root x minus 2 times square root x plus 2. I'm going to do it the long way here, and I'm going to do it the short way on the left side. So this is using FOIL. I would have square root x times square root x, so that's just going to be square root of x squared, so it's x. And then I have square root x times 2, so that's plus 2 square root x. Inside, negative 2 times square root x is negative 2 square root x. And then my last would be negative 2 times a positive 2, so that's negative 4. What you notice here is I have x, and then right here I have plus 2 square root x minus 2 square root x. And this is why we multiply by the conjugate, because what happens is it gets rid of that middle term. 2 minus 2 is a 0, so I have 0 square root x, which is just 0. So this actually equals x minus 4. So what simpler form of doing this, and you know you're going to do this every time because you're multiplying by the conjugate, is to square your first term. So square root of x times square root of x is square root x squared. Square root of x squared is just an x. And then you know you're not going to have a middle term, so you don't have to worry about doing the O and the I of FOIL. You go straight to your last term. Negative 2 times positive 2, negative 4. And that's it, the answer's done. So the whole point of using the conjugate, using the opposite sign, is to get rid of your radical, so getting rid of that square root or cube root, whatever it was, and also getting rid of that middle term. So simplify 6 times square root 3 over 4x, and x is greater than or equal to 0 is a stipulation, because again, we can't have a negative value in that x because this is an even index. So the first thing we want to do is we want to rationalize that denominator. So this is going to be 6 times square root 3 over square root of 4x, which means that's the radical, or that's the rational I'm trying to get rid of. So I multiply by square root 4x over square root 4x. So this equals 6 square root 12x all over 4x. Square root of 12x. 12 is the same as 4 times 3. Oops, that should be under the radical. So square root of 4 is a 2. I can't do anything with 3, doesn't square, and neither does x. So really, this is 6 times 2 square root of 3x all over 4x. My 2 and my 4 will reduce. I'll just write my answer up here will be 6 square root of 3x times, or divided by 2x. But I'm not done because now this 2 in here can reduce into that one. So what I'm left with is 3 square root 3x all over x. And that's your answer. And remember, x cannot equal, or has to be greater than or equal to 0. Okay, B. So this is another question like the second example from just above. On the bottom, I'm working with the cube root of 9p. So in order to rationalize this denominator of cube root of 9p, I'm going to have to go one index down and multiply top and bottom by that. So this is going to equal negative 7 over 2 cube root of 9p, oops, times cube root of 9p squared over cube root of 9p squared. So the first thing I want to do is I have to do this cube root of 9p squared. So this equals negative 7 cube root of 81p squared. And on the bottom, I have 2 times. Now remember, the whole purpose of multiplying for rationalizing the denominator is getting rid of the radical. So this squared and the cube root and the cube root here will cancel each other, so it just leaves me with a 9p. (81), as it turns out, has a cube root in there. 27, which is 3 times 3 times 3, divides evenly into there. It's 27 times 3p squared. So that's all over 18p. It's going to go up here. So cube root of 27 is the same as a 3. That leaves me with 3p squared, cube root of 3p squared, all over 18p. Well, 3 can divide into 18 evenly. 3 goes into there once and into there 6 times. So my answer is going to be negative 7 cube root of 3p squared all over 6p. And your answer is done. Okay, C is an example of a binomial in the denominator. So binomial in the denominator here means I need a conjugate in order to rationalize that denominator. So 3 square root 5 minus 4 means that the conjugate is going to be 3 square root 5 plus 4. So on the top, that means I'm going to FOIL. So 2 times 3 square root 5 is 6 square root 5. 2, what did I do? First times first, outsides. 2 times 4 is 8. Inside is square root 2 times 3 square root 5, so that's 3 square root 10. And my last is square root 2 times 4, so 4 square root 2. Now on the bottom, I'm going to do the short way of doing this because the whole purpose of multiplying by a conjugate is to get rid of your root, or your radical sign, and to get rid of your middle term. So what I have then, I just do first and last. So first times first is 9 times 5. Square root 5 times square root 5 is just 5. And then I have negative 4 times positive 4, so it's negative 16. So I check and see, do I have any like terms? And I don't. Square root 5, square root 10, I can't do anything. Square root 2, so those all stay the same. So this is going to be 6 square root 5 plus 8 plus 3 square root 10 plus 4 square root 2 all over 9 times 5 is 45 minus 16, which is 29. Okay, so when you're doing questions like these, you have to first check and see what is my index value. If my index value in the denominator is greater than 2, I'm going to have to multiply by an index of 1 less than that to get rid of the rational in the denominator. If the denominator is a binomial, I have to multiply by the conjugate.